Next we have horizontal asymptote. So any horizontal line looks like, the equation looks like y is equal to a constant, is a horizontal asymptote of the graph of function f if f of x approaches d, that constant, you see this number and this number is exactly same, as x approaches to infinity or negative infinity. So when x is approaching to, in this, these are few of the examples of horizontal asymptote. If you notice, x is approaching to negative infinity, the graph y value is approaching almost equal to d. So that's why y is equal to d is a horizontal asymptote. That is the equation of this red line. Similarly, in this case, when x is approaching to negative infinity, function is approaching to the value d from below. So still y is equal to d, that red line is your horizontal asymptote. Or when x approaches to infinity, the positive infinity, and the graph is approaching to d, that d value, then the horizontal from above, the horizontal line, this red line, which is y is equal to d, is your horizontal asymptote. Or when x approaches to infinity and the function approaches to d from below, still that horizontal line is your horizontal asymptote. Now, while the graph of a function may never cross the vertical asymptote, but sometimes it does cross horizontal asymptote. Sometimes curve would just pass through the horizontal asymptote and then it would keep approaching your that horizontal line value. Now we have to learn how to find the horizontal asymptote. Let's learn the method first. If f be any rational function, what does that mean? There is a numerator and there is a denominator, right? Defined by a polynomial f of x is equal to, let's say this is p of x divided by q of x. Px is the numerator and qx is the denominator. Both of them are polynomial functions. The definition of fx indicates that n is the degree of the numerator, right? And m is the degree of the denominator. If n is more than m, then f has no horizontal asymptote. Or you can also remember it like, if degree of numerator is more than degree of denominator, then we have no horizontal asymptote. On the other hand, if n is less than m, that means the degree of numerator is less than degree of denominator, then we have y is equal to 0, which is x-axis. The horizontal x-axis is your horizontal asymptote of the function. The last one, if n is equal to m, or you can say the degree of numerator is equal to the degree of the denominator, then the horizontal asymptotes is written as y is equal to an by bm. What is an? That is the leading coefficient of the numerator divided by the leading coefficient of the denominator. Let's try these. So we have to find the horizontal asymptotes of these following functions. Let's look at the first one. F of x is equal to 8x squared plus 1 divided by x raised to power 4 plus 1. So I have to check degree of numerator. The degree of numerator in this case is 2 and the degree of denominator, which is m, is equal to 4. N is equal to 2. N is less than m. Which case is this? That is this case, n is less than m. That means y equal to 0, which is x-axis. So y is equal to 0 is your horizontal asymptote. Let's try the second. In this case, the degree of numerator is 3. M, the degree of denominator is 2, and n is more than m. So according to this first rule, if n is more than m, we do not have any horizontal asymptotes. So we're going to write no horizontal asymptote for this particular function. What about the last one? What is the degree of numerator here? 2. What is the degree of denominator? Is also 2. N is equal to m. That means horizontal asymptote can be written as y. Because of this last rule, y is equal to an by bm. An is the leading coefficient of the numerator. Bm is the leading coefficient of the denominator. So we have this is equal to 8 by 2. So y is equal to 4 is your horizontal asymptote. Next we have the function h of x is equal to 8x square plus 9x minus 5 divided by 2x square plus 5. We have to find where the graph crosses horizontal asymptotes. First, let's find horizontal asymptotes. Degree of numerator, which is n, equal to 2, and degree of denominator, which is m, is equal to 2. So, horizontal asymptote can be written as y is equal to an by bm, which is 8 by 2, 4. So, horizontal asymptote is y is equal to 4. Now, we need to see where this graph actually passes through the horizontal asymptote, meaning where function's value would be equal to 4. So, we can say 8x square plus 9x minus 5 divided by 2x square plus 1. Where does it becomes 4? So, we have to find where, meaning we have to solve this for x. Let's do that. We can cross multiply to get 8x square plus 9x minus 5 is equal to 4 times 2x square plus 1. 8x square plus 9x minus 5 is equal to 8x square plus 4. 8x square is on both sides the same side, it can cancel. 9x minus 5 is equal to 4. 9x is equal to 9 by adding 5 on both sides. X is equal to 1. So, at x is equal to 1, the graph passes through crosses the horizontal asymptote. Let's check it on Desmos. So, I went ahead and wrote this function h of x from here on the Desmos. Let's look at the graph. So, if you notice, this is the graph. Let's also plot the horizontal asymptotes. We said that the horizontal asymptote is y is equal to 4. So, let's write here y is equal to 4, another line. So, if you notice here, this red line is y is equal to 4. Y is equal to 4 is the horizontal asymptote clearly, as you see this branch and this branch, but it crosses the graph at a point. Where is it crossing? At x is equal to 4. So, y value is 4 and x value is what? 1. So, that is what we solved. We said the function h of x crosses horizontal asymptote, which is y is equal to 4 at x value 1, at value 1, 4. So, we worked on horizontal asymptotes and we worked on vertical asymptotes. We can also find slant asymptotes. A rational function will have a slant asymptote if the degree of numerator is exactly 1 greater than this. So, this is very important. When can we have slant asymptote? When degree of numerator is exactly 1 more than the degree of the denominator. So, we can simply say that degree of numerator is exactly 1 more than degree of denominator, meaning it will be degree of denominator plus 1. To find the equation of slant asymptote, what do you have to do? You have to divide the numerator of the function by the denominator. The quotient will be linear and the slant asymptote would be y is equal to quotient. Okay, so let's see. We have this question number 4. It says find all the asymptotes. Okay, so first of all, let's work on vertical asymptotes. For vertical asymptote, we need to find denominator, which is x minus 2, find its 0, so that is x is equal to 2, and that equation would be vertical asymptote. Next, we have to find horizontal asymptote. For horizontal asymptote, we need to find the degree of numerator, which would be n, which is 2 in this case, and the degree of denominator, which would be m, which is 1 in this case. N is more than 1 m, so we will have no horizontal asymptote in this case. If the degree of numerator is more than degree of denominator, then we will have no horizontal asymptote. Last one, let's find slant asymptote. How do we find that? First condition was that the degree of numerator, which is 2, should be 1 more than the degree of denominator, and the degree of denominator is 1. So degree of numerator is 2, which is exactly 1 more than degree of denominator. So we have a slant asymptote. How do you find it? You divide the numerator by the denominator. Let's do. How can we divide the numerator? Let's use the long division. Numerator was 2x square minus 5x minus 3. Denominator is x minus 2. We have to divide. So what should we multiply x with to get 2x square? That number would be 2x. So 2x square minus 4x. We subtract, change the signs. We add, what will we get? Negative x minus 3. What should we multiply x with to get negative x? So that will be negative 1. So negative x plus 2. Subtract means changing signs. We have negative 1. So that is your remainder. But what is the quotient? The most important is the quotient in this case. So slant asymptote is written as y is equal to quotient. That means y is equal to 2x minus 1 will be your slant asymptote for this particular, that's a linear equation, right? That's the equation of a straight line. Let's look at this in Desmos. So I went ahead and I wrote this function in desmos.com. Now I'm going to try to show you how this is slant asymptote. So y is equal to 2x minus 1. So notice how this blue is the function, right? The curve given, and this purple line is the equation y is equal to 2x minus 1. You see how as we are approaching towards infinity, that graph is almost approaching to that straight line. So that straight line is your slant asymptote for this particular function.